Here's pre-calc. This is a mini lecture for 8.3.5. So we're going to do 3 problems together as though we were in class, but it's going to be a little faster. So 8-145, it's solving complex trig equations. So sometimes if you're asked to solve something like this, that could be a little difficult. So the first thing you want to try to do is get the whole thing either in sine or in cosine, so it's all in the same trig function. So what you can do with that is go ahead and use the fundamental Pythagorean identity, and you can hopefully you can see that I substituted in for cosine squared theta. I went to the fundamental Pythagorean identity and I said that 1 minus sine squared theta is equal to cosine squared theta, like I minused sine squared theta from both sides, and I swapped that in for cosine. So now I can distribute to my 2, and I have all the same function. I don't have sines and cosines. I want it all in sines. And I don't know if you recognize this, but I've done this a few times. I see this looks like a quadratic that I could factor. Well, if I use a u substitution. So I kind of put it all in order. I don't like it when there's a negative on my lead coefficient, so I just kind of like brought everything to the other side, or you could say I multiplied both sides by -1. So I have this, and I can think of this as a little quadratic for myself to solve. I let u equal sine x, and so this gives me a nice quadratic that I can do a diamond problem on. So I did my factoring, my diamond problem, factored it out, used zero product property. I get -1 from this factor, and I get I get positive 3/2 from this factor, and that's u. But remember, we said u was equal to sine x. So now I can sub it in for sine x, and then I just ask myself, well, where on the unit circle is sine x equal to -1? And I just got out my unit circle, and I know sine is the second number here, so all the way down here. So that's 270 degrees, which is the same as 3 pi over 2. That's where sine is -1. So 3 pi over 2. And then here we have u is 3/2. Well, I didn't even bother with that one, because if I put in sine x equals 3/2, is there anywhere on the unit circle where the sign is going to be 3/2? The biggest sign can get is 1, or it's in between 1 and -1. So this one is just a no solution, and here's our solution. Okay, so that was a quick little walk through how to do these problems. You just have to do a little substitution so that you get them in the same, like have it all in cosine or all in sine, and then you can factor or do whatever is necessary. The next problem I want to show you is 8-147. I just wrote it in the book. It says the angle sum and difference identities can also be used to solve trig equations. Use the angle sum identities to solve this one. So it's sine x plus pi plus cosine x plus pi equals negative cosine x. So sine x plus pi, I thought of that as my angle sum identity, like sine a plus b, and I'm going to give you guys one of these next time I see you. But so I just looked on the wall. Remember, we have those on the wall, but we found out that sine a plus b is sine a cosine b plus cosine a sine b. So I wrote it out. Sine a cosine b, because a is x and b is pi, plus cosine a sine b. And then plus, well, the cosine x plus pi, which is cosine a plus b. So now I looked on here for cosine a plus b, here's cosine A plus B. It goes cosine A, cosine B minus sine A, sine B. So I went cosine A, cosine B minus sine A, sine B. I'm calling x's A, and I'm calling pi B. And then I realized, I just got done looking at my unit circle for something else. I realized these ones that are on my unit circle, like cosine of pi, if you look on your unit circle, that's equal to -1. Because that's pi. Okay, so I'm going to sub in, I have sine times -1. Well, that's just negative sine. And then sine of pi, we know that one too, it's 0. So I got cosine x times 0, so I just zeroed that out. So basically, over here I've just got negative sine. And then cosine of pi, well that was -1, remember. -1 times cosine x is negative cosine x. And then I had all that whole thing was equal to negative cosine x. But then I just added cosine x to both sides, and I had negative sine x equals 0. Divide both sides by 0, I got sine x equals 0. And sine x equals 0 at pi. Sine x equals 0 at pi. And also 0 and 2 pi. But so there's lots of actually at pi and at 2 pi. It can go around, so we're going to say pi times n. That was 8-147, and then the last one we're going to do is 8-148, which is right here. So 8-148, it just walked us through, and it said, what about the double angle identities? What if we want you to solve this thing? Well, this almost, you could almost recognize it as a double angle identity, kind of, sort of. See, remember we have them on the wall? The double angle identity is 2 sine x cosine x. Well, if I had a 2 there, that would be 2 sine x cosine x. So the book walked us through this. We didn't figure this out on our own. They said, okay, everybody, multiply both sides by 2. So I multiplied both sides by 2, and I got 2 sine x cosine x equals a half. Well, 2 sine x cosine x is the same as sine of 2x. So then I just wrote it as sine of 2x equals a half. And they're telling us all along, if you read along in your book on 8-148, they're telling us what to do. And then they said use a u substitution. Let u equal 2x. That kind of makes sense to me. So sine of u is a half. Well, I can go look on my unit circle, and I can find out where is sine equal to a half. Well, it's just basically right here and over here. So what is that? It's pi over 6 and 5 pi over 6. So I wrote those in, and then remember that u was equal to 2x, so I substituted back in my 2x, and then I multiplied both sides by 2. Or no, sorry, I divided both sides by 2 to get x by itself, and then I got pi over 12. And then it even said in our book, they were doing us a favor. They said, don't forget to write 2 pi n after, because that we didn't have it restricted to just in between 0 and 2 pi. We did the same thing here, divided both sides by 2, and we ended up with that. And that's your mini lecture. That's what we would have learned if we would have had class today.